Excellent. Thank you, sir. All right, so Chapter 2 is fractions. Chapter 3 is the next extension after that, which, of course, is working with decimals. So before we jump into actually working with them, I like to just make sure that you guys can read numbers first. This is a silly exercise, and I won't ask you to read numbers to me on a test or anything like that. It's kind of silly. But the idea is when you read numbers, when you read them in two parts. You read the stuff that's before the decimal and then the stuff that's after the decimal. Please note that the only time you say the word "and" is when you reach the decimal point. If you say the word "and" before you reach the decimal point, you haven't said the number correctly. All right? So sometimes it takes a little bit of work to get to that "and," and it's, we get a little lazy as Americans when we speak. We'll often say, well, this is 4,000,000 and 375,000 and 622 and 123 thousandths. Technically, that's wrong. When I hear the word 4,000,000 and, what I think is 4,000,000 and whatever number you're saying afterwards is a number that's coming after the decimal, because that's what the "and" is for. It's strictly for the decimal point. So when you read these numbers, and again, it's the sort of thing where you don't think about it, but if you're going for a job in a bank, which deals with numbers this big on a regular basis, even bigger, right? They are going to want you to read the number correctly. They're going to want to hear 4,375,622 and 123 thousandths. Okay? When you're reading to the right of the decimal, you read the number like it's to the left of the decimal, and then at the very end, you add that at the end. Okay? And I will try not to spit on you guys, but this is decimal, so there's lots of and so just put your shields up. All right, so please read numbers correctly when you are in situations where it's going to make a difference. All right? Now, so this is the "and." And again, please remember ones, tens, hundreds, etc., right? Thousands, 10,000s, 100,000s, millions. What comes after millions? Billions. What comes after billions? Trillions. What comes after trillions? We don't know. It's actually quad billions. All right? So, again, you have to get out to at least trillions, folks, because what's our national debt as a country? 17 trillion some odd dollars. You need to be able to write out to the trillions. Okay? That's a minimum. Right? Again, please be careful with decimals, and I've seen this way too often that we get lazy. And we think that when you go to the right of the decimal, it's the same as going to the left of the decimal. It's not the same. What's this spot right here? Tenths, right? Oneths. We start at tenths, okay? This is tenths. But then all the progression is exactly the same, except you skip the ones, right? So this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, etc., etc., etc. Okay? So if I ask you to round something to a specific place marker, please know where that place marker is. Okay? And that's something that you may be asked to do. Again, that's one of those quiz questions that I threw at you at the very beginning to sort of jog your memory about where decimals are. Okay? So please be careful with the thysses. All right, now. So, rounding, something we have to do. 8,159.9918. So we are going to round this to different places. Round to the ones place. When you are rounding a number, ones, that's this spot. Look at the number to the right of you. If that number is 5 or more, round up. Rounding up means add 1 to this number. What's 9 plus 1? 10. Please add correctly. So when you add a 1 to this, this becomes a 0. You have to add 1 to the 10 spot. 8,160. Please note that everything to the right of wherever you round to is just zeros. Don't write them. It's okay if you write 0.0, but it's actually, in a technicality perspective, not correct. When you round to a specific place marker, everything to the right of it should be blank. Blanks and zeros are the same, so that it's okay, but people would frown at you if you did that. All right? So, if I ask you to round this number to the thousandths, again, tenths, hundredths, thousandths. Here is your thousandths. What's to the right of it? 8, that's 5 or more. Round this number up. You only round that number up. Don't round everything else up, right? So this, 8,159 and 992 thousandths. All right? So if I want to round this to the hundredths,
So when you round on that side of decimal, you go to the right.
you always go to the right, no matter which side of the decimal you're on. Always. But when you write these numbers, you might have to fill in some zeros. Over here, don't have to. If you're rounding to the hundredths, go to the hundredth spot. What number is to the right of that? A 1. Do not round up. Stay right where you're at. Write the number. 8,159 and 99 hundredths. Okay? So, if I ask you to round this number to the tenths, here are our tenths. What's the number to the right? 9. Add 1 to this 9. It's a 0. It's a 0. You add things the way you've been adding them forever, right? Since I rounded to the tenths, please write it to the tenths, right? So when I rounded it to the ones or the tenths, technically the number is the same, but you always write it to wherever you're rounding it to, okay? So when you round to the ones, write to the ones. When you round to the tenths, write to the tenths, etc. Please read carefully. If I asked you to round to the nearest thousand, there's no antithesis. Tens, hundred, thousands. $8,000, right? 8,000, the one next to it here. Don't round the 8,000 up. I could ask you something weird like round to the nearest 10,000. Where's the 10,000 space in that number? There's nothing. What would you put there when there's nothing there? Right? Remember, there's technically a number there, right? There's a whole ton of zeros, as many spaces out as we need to go, right? So here is the 10,000 spot. What number is to the right of it? An 8. What do I have to do? Round up. 0 plus 1. Okay? So don't freak when you're asked to round to a place where you potentially don't have the number. Just, you know what numbers are there. Likewise to the right of the decimal point, right? If I asked you to round it to the nearest millionth, you would just have to add some zeros, okay? Just, again, it's one of those where read it, okay? The reading is important, and then follow the rules. If it's 5 or above to the right of you, round it up. If it's not, keep it the same. All right. Are we good with rounding and reading? So, you need to be able to add decimals, right? $15.52 plus 0.151 plus 2.4. How do you add numbers when they have decimals? Line the decimals up, right? 15.52, 0.151, 2.4. Just be careful. If you want, there's nothing wrong with it, fill in zeros so that you have numbers to add if you sometimes know that visually you get a little bit sloppy. Adjust. I mean, you know yourself better than I do, so do what you need to do so that when you add these numbers, 1, 7, 0, carry your 1, 18 and 71 thousandths. Do I need to do another example of that? Okay, just line the numbers up. If you add them, guess what else you have to be able to do them? You have to be able to subtract them as well. So if I ask you to subtract 8.1 minus 3.45762, do the same thing. Line the decimal points up. And again, fill in everything that you need with zeros accordingly, right? And then subtract the way you've been subtracting since 4th or 5th grade. When this number is less than that one, borrow the way you used to do, right? 9990. This is now a 10. When you got a whole bunch of zeros, you got to keep borrowing and borrowing and borrowing from the next one over. 10 minus 2, 8. 9 minus 6, 3. 9 minus 7, 2. 9 minus 5, 4. Here, you got to borrow from the 8 to make that a 10. 6. 7 minus 3 is 4. And when you subtract things, folks, it's generally my advice after you do the subtraction, just to be safe, add them going back up and make sure you get the result that you're supposed to, right? If you're taking this number minus this number to get this number, you have to be able to add this number and that number and get to this one. That's a great check, right? I mean, 8 and 2 is 10. Carry your 1, 0. Carry your 1, 0. Carry your 1, 0. Carry your 1, 11. Carry your 1, 8. Okay? That's a great little quick check for whenever you do these subtractions. Again, remember, the first test I give you has half calculator, half non-calculator. If you sometimes bungle your subtraction, because you know you do, because it's perhaps been a while, check. Never a bad idea, okay? All right. Adding and subtracting. After you add and subtract, you got to multiply. Multiplying decimals. 2.15 times 0.042. When you're multiplying decimals, folks, you do not have to line the decimals up, okay? In fact, you're not supposed to. When you do this, you write it just like you would write it without the decimal being there. It's just like this is 215 times 42, except the decimals are not really there. All right, so actually what I tell students a lot of times is think of this as 215 times 42. Because those are the numbers that you're really multiplying, okay? When you multiply these numbers, remember your long multiplication, right? So you're going to start with the 2, multiply by the 5, 10, 0, carry the 1, 2 times 1 is 2, plus 1 is 3, 2 times 2 is 4. When you move to the tens place, remember that you're taking 40 times this, so you add a 0 to begin with and then start the multiplication process, because this is really 40 times that number. 4 times 5 is 20. 4 times 1 is 4, plus 2 is 6. 4 times 2 is 8. 0, do I need to multiply zeros? What do you get when you multiply by 0? You can write them down if it makes you happy. But if it's just a bunch of zeros, don't sweat it. Add the numbers like you did back when you were learning multiplication back in the early days. 9,030. Technically, here's where the decimal point comes into play. It starts at your first number. Count the number of decimal points in your two numbers. There's 2 here. There's 3 here. Therefore, you need 2 plus 3, 5 decimal places. So 1, 2, 3, 4, 5. That's where your decimal point goes. Fill in any blanks with zeros. Okay? So 2.15 times 0.042 is 0.09030. You don't have to write that 0, but there's nothing wrong with it if you want to, right? Generally, when there's zeros to the right on the decimal point, you can not worry about them. Are we good with this? Okay, I'm going to do one more just because you're making me a little nervous. I want to make sure. It's never hurts to review. 44 times 2.11. Again, when you're multiplying numbers, it doesn't matter the order that you multiply them. In general, my advice to you is always put the shorter number below, right? You don't have to, but it generally makes your number easier. 4, 4, 8. Nice thing about 44. You're going to get the same number twice. Again, add the numbers. Once you have your result, count the number of decimal places. How many decimal places are there in 44? None. 2.11? 2. 0 and 2 is 2. Just be careful. It's good old long multiplication. You did this a while ago, so jog your memory a little bit. Not bad. What comes after multiplication? Division. Oh boy. All right, so division tends to be the harder problem when dealing with decimals. Let's start with something relatively straightforward. Let's say 8 divided by 0.5. Now, you guys are clever. What is 0.5? It's a half. So you could, since you guys are smart, right, that's really just 8 divided by a half. How do you divide fractions again? Flip and multiply, right? This is really 8 times 2 over 1. What's 8 times 2? 16. Okay, let's make sure that we can get 16 when we divide this. Okay? When you're dividing decimals, folks, it's long division. A little bit of review of long division, never a bad thing. All right? Whatever you are dividing by goes on the outside of the division symbol. Whatever you're dividing into goes into the long division symbols. And what you were told back in 3rd or 4th grade, if you were lucky, I've heard some rumors that they don't do long division in school anymore. That would be a shame. Oh, I hate that. It's so good to be able to do that stuff in your head. When you are dividing with decimals, folks, the key here is what you're dividing by. This number should never be a decimal. The way you get rid of it is move the decimal over to as far as you need to go so that you do not have any decimal numbers to the right of the decimal point. However far you move this decimal point, you move this number same number of hops. The reason why that works, folks, is that this is really 8 divided by 0.5, or 8 over 0.5, right? When I am hopping this decimal to the right 1 place marker, I'm multiplying by 10. If I multiply the bottom of a fraction by 10 to not change the number, what do I got to do? Multiply the top by 10, right? So 8 over 0.5 is really the same as 80 over 5, or 5 divided into 80. That's why that works. That long division technique, all you're really doing is converting it into a fraction and then playing with the fraction so that you don't have any decimals anymore. That's it. You're multiplying by tens. That's why this long division stuff is really cool, because it drives home the point of multiplying by 10. When you're dividing decimals, you don't do it. What you do is you convert all of your decimals into good old regular whole numbers and do good old regular whole number division. That's all there is to it. Right? So it looks like this is really scary. It's not. It's just us taking a little bit of a smart shortcut so that we get rid of decimal points, because they tend to cause us a problem, right? Again, though, when you divide 5 into 80, drop the 0 down, except 8 minus 5 is 3, not 1. Subtract correctly. How many times does 5 go into 30? 6. When you run out of numbers, just make sure you keep your decimal point in the right space. 8 divided by 0.5 is 16. Okay? So long division, the reason that you're moving the decimals, and you have to move the decimals both the same number, is that this is all you're doing. Just multiplying by tens. That's it. All right? No, you keep the decimal right where it's at. So it's 16. All right, so let's try another one. One that you can't just convert into a fraction and do it. So let's say I take 2.15 and divide by 0.016. Okay, so again, note where what we're dividing by goes, right? So this 0.016 goes there. What we're dividing into goes into the long division symbol. And again here, you got to be careful, right? How many times do I have to move this decimal point? 1, 2, 3. In other words, I'm multiplying by 1,000. If I multiply the bottom by 1,000, I got to multiply the top Same thing. 1, 2, 3. Again, fill these in with zeros. Note that the decimal point does stay right where it is. .016. Do I got to worry about the 0 in front now? Again, yeah, we got rid of it. That's what multiplying by 1,000 allows us to do. Now we don't got to worry about it. So how many times does 16 go into 2,150? This is where you got to be a little bit cautious. 16 goes into 21 how many times? 1. Make sure you write the 1 over the 21. All right, that guarantees that you'll have the right place markers when you come down to the end, right? 1 times 16 is 16. 21 minus 16 is 5. Drop down the 5. How many times does 16 go into 55? 3. 3 times 16 is 48. 55 minus 48. 7. Drop the 0 down. How many times does 16 go into 70? 4. Let's suppose that you accidentally made a mistake, okay? So you know it's 4. Don't erase anything. Just watch this thing and discover with me, okay? Let's suppose that you didn't use 4 correctly and you used 3 instead, right? Just for kicks and giggles, right? Suppose you put in 3 here. 3 times 16 is 48. When you subtract 48 from 70, anytime you ever do long division and this number here, the result, is more than that number here, you screwed it up. This number can be 1 larger, okay? That's a great little visual check you can do while you're doing long division. If you do the multiplication and subtraction and wind up with a number that's bigger than that, make the correction, okay? This should have been 4. This is 64, 6. If you do not have a remainder of 0, you don't get to stop. Sorry. When you're dealing with decimals, you got zeros going as long as you need, folks. This could take a while. Just be patient. That's if you start to see repetition. We don't see any repetition yet, right? But we have this 0. The 0 comes down here. Note that now we are to the right of the decimal. That's why you got to be careful. Where the decimal goes is very important, right? But how many times does 16 go into 60? Back to 3. If you still have a remainder, you still have a 0. Keep it going. 16 into 120. Seven. 7 times 16, 112. Not quite there yet. Keep going. We have more zeros. How many times does 16 go into 80? 5. And what do you note about 16 times 5? 80. Once you get a 0, that's when you're done. You don't have to do any more. 134 and 375 thousandths. Cool thing about 16, right? This is 2 times 2 times 2 times 2, right? It's 4 2s. Anytime what you're dividing by is a power of 2, your fraction, your decimal will always end at some point in time. Has to, okay? That's a nice thing about 2s. So don't be surprised if this number is something like 8, 16, 32, all of those multiples of 2, they're going to terminate, right? Now, if it doesn't terminate, what do? One way that we used to do it was working with the remainder, but now that we're in decimal format, folks, now we have to deal with repeating decimals. All right? You guys should be able to work with repeating decimals. So if I asked you to do 1 divided by 3 or 1/3 and write it as a decimal, the technique is exactly the same as what we were doing just a second ago. It hasn't changed at all. That's the cool part about having decimals that don't terminate. Whenever you are dividing by something that is a multiple of 3, that's when you're going to get repetition. That's a giveaway. All right? The technique, though, is still the same, right? We're going to take 3 and divide it into 1. Add zeros, right? However many you need. Again, keep the decimal careful. Here's where it is. How many times does 3 go into 10? 3. 3 times 3 is 9. 10 minus 9. 1. Drop another 0 down. How many times does 3 go into 10? 3. 3 times 3 is 9. 10 minus 9 is 1. Not done yet. Keep going. Can't stop until you get a 0, folks. What? What do you mean line at the top? Have you ever read a newspaper article or a banking report and seen a bar over a number? Oh, well, okay, yeah, so have I. But, yes, once you note that a pattern is repeating, you should note that and adjust accordingly, right? This is 0.3 with a bar over the 3 because the 3 is going to keep going and going and going and going. If you have children that are gullible and are at that age where they're learning division and you want to teach them long division, this is a great way to kill 5 to 10 minutes. Kids will go for a long time.
You don't have to do it like a couple times and then fill in at the end.
If you put more than 1 3 up here, if you say, suppose you did, they're all the same. When there's just one number repeating, it's okay. Right? Now, be a little cautious. How would you write 5/6 as a decimal? It's not 5/6. It's really 5 divided by 6. Crank it out. You now can do it. Whatever's in the denominator, whatever's in the numerator, add your zeros. How many times does 6 go into 50? 8. 6 into 20? 6 into 20? 6 into 20? How many times do I need to go? Yes, please note that in this first fraction, 1/3, the entire 3 was the one repeating over and over and over again. Note here that we have a number 8 that's not repeating, right? That 8 doesn't repeat at all. Don't put the bar over the 8, right? This is 0.83 with a bar just over the 3, because the 3 is the only thing that's repeating. That's what you got to be a little bit cautious of, right? And again, please note that most of your calculators probably will not be able to do this, right? Have you ever seen a calculator give you the repeating decimal by putting a bar over the top? There's a couple of them out there that do. They're really expensive. They're almost as much as buying a computer or a tablet, which I would recommend over that type of calculator. They're out there, but most of them, if you got the $10 cheapie at Kmart like I will get, it ain't going to do it for you. You have to be able to do, on the calculator, 5 divided by 6. And when you see 0.8333333, know that 3 is really repeating forever, okay?
How come on the first one you took the 1 and divided by 3, but on the second one you took the 6 and divided it by 5? You flipped it.
No, it's the same. This is 1 over 3. Whatever's in the denominator goes outside. Whatever's in the numerator goes inside. Whatever's in the denominator goes outside. Whatever's in the numerator goes inside. Pattern the same, right? Because 5 over 6 is the same as 5 divided by 6. So let's try another one. Now one that's going to be fun. Oh, fun for me. So let's try, say, 3/7. This is my marker for how far the camera fits. I get too excited when I get to those repeating decimals. That's good stuff. Yeah, I know. All right, so 3/7. Again, same thing. Remember that the denominator is what's outside. The numerator is what's inside. Give yourself zeros. Note how many zeros I gave myself. Oh, it might be a hint. Again, be careful with your decimal point. So 7 divides into 30 how many times? 4. 7 times 4 is 28. 30 minus 20 is 2. Bring it down. 7 into 20. 2. 2 times 7 is 14. 6. Bring another 0 down. 8. 60 minus 56. 4. Bring a 0 down. You see any repeating yet? 7 into 40. 5. 7 times 5 is 35. 40 minus 35, 5. Not done yet. Keep bringing that 0 down. 7 into 50. 7. 49. 1. The nice thing about fractions, folks, is that they have to have some sort of repeating decimal. Have to. That's the definition of a rational number. A rational number, which can be written as a fraction, must have some sort of repeating decimal. It has to. There has to be a pattern. You just have to keep going until you find it. 7 into 10. 1. 7 times 1, 7. 3. Uh-oh. We're starting back over, right? Because how many times does 7 go into 30? 4. And once I do that, what's going to happen? Same thing. I'm going to get the 2. And what's going to come after the 2? The 8. What's going to come after the 8? The 5. So here, 4, 2, 8, 5, 7, 1. And after the 1, what happens?
4.
Goes back to the 4. Now, your calculator can't show you all these numbers, right? Calculator's going to only show you 6, 7, 8 numbers, maybe. You are smarter than that, right? You are smarter than your calculator. What numbers are repeating? The 4, the 2, the 8, the 5, the 7, and the 1. So this number as a decimal, 4, 2, 8, 5, 7, 1, that entire pattern repeats over and over and over again. That's cool, because this is really hard for a calculator to do, right? Right? That's why the really expensive ones are the ones that'll be able to do this, because you got to write some really fancy programming code in order to be able to do it. All right, so let's see. I got a little bit. Let's do one more, and then I want you to think about it to get from one to the other. So I want you to tell me what those decimals are as repeating decimals, 1/11th and 1/110th. So do this one first, and then you can do this one the long way, or you can be clever. Be careful. So again, this one. The reason I like to do this one, how many times does 11 go into 10, folks? Can't, right? It's a 0. Don't lose that 0. That tends to be one of the things that we tend to skip. We're like, oh, well, it can't go in there, so I'll just hop over one more. But since it's after the decimal, it's really important that that 0 is there, right? How many times does 11 go into 100? 9. Drop a 0 down. How many times does 11 go into 10? 0, right? If it doesn't, that means you use 0, right? Now we have another 100. What's repeating this time? The 0 and the 9. The 0 and the 9 are repeating over and over and over again. It's going to be 0, 9, 0, 9, 0, 9, 0, 9, 0, 9. How am I going to get 1 over 110? There's going to be 2 zeros in the front. The way to think about this is that you know what this is, right? 110 is 11 times 10, right? What's 1/11th? 0.0909090909. What happens when you multiply by 1/10, though? You move the place of the decimal point, right? So we really have 0.090909, and we want to move the decimal 1 to the left, right? Because that's what multiplying by 1/10 is, same as dividing by 10. So that this is 0.009090909. Does this 0 repeat? No, just the 0.9. That's cool stuff, folks. Yeah. So we divided it by 10. Guess what 10/11ths is? Remember, this is 10 times 1/11th, right? When you multiply by 10, what do you do at the decimal point? Move it to the right, right? So if this is 0.09090909, and I move the decimal point 1 to the right, 909090990, this is just 0.90 with a bar over the 90. Again, these are the sorts of things that once you get comfortable playing with tens and just shifting decimal points, then all of this repeating crap, well, once you get the repetition, now you can see. We'll just hop right, hop left as needed. You have no idea how cool that is for me. All right, anyways, that's the decimal section. The homework for Chapter 3, all the evens at the end. I have put them on Blackboard. I put them on this morning, so please note, though, we're going to skip a couple of them. Please skip questions 38 and 40. So the homework in Chapter 3, which are pages 81 through 84. Two through 84, the evens. 86 is again extra credit. Skip 38 and 40. Those questions talk about rounding all the way. I don't give a crap about rounding all the way. I think it's stupid. Please don't bother. So if you're going to read the section in Chapter 3 and you get to the part about rounding all the way, you can read it, but use it as bathroom reading material. That's about how it fits in my world. We will review this on Monday of next week. Next week goes back to being a regular old week. So normally on Mondays we will review the homework. Turn it in if you're happy with it. If not, it needs to be turned in before Wednesday. Please note that next week we will skip to Chapter 5. We skip Chapter 4. And then again in 2 weeks from today, first test over Chapters 2, 3, and 5. Good. Excellent. Thank you.